Hello everyone, I am Mohammad Sirdaha of CSEC and today's my seminar topic is about graph and its representations. And before going to that, my register number is 23BQ1A05 and as you can see that a graph consists of vertices, that is in this graph you take it as an example A, B, C, D and E are the vertices of the graph, and here A and B have a common edge, that is E1, and A and C have a common edge, that is E2, and C and D have a common edge E3, and D and B have a common edge E4, and A and D have a common edge E5, and D and E have a common edge E7, and B and E have a common edge E6. So we know that graph has vertices and edges, and to know its representation, graph is represented in three forms depending upon its densities. Okay, first is adjacency matrix. Adjacency matrix is a sequential representation. It is used to represent which nodes are adjacent to each other. That is there any edge connecting nodes to a graph? Here, let's go to an example to know in more detail. Undirected graph representation. Here, you see there is a graph consisting of vertices A, B, C, D, and E, and here D is forming a loop internally from D to D, and to know it clearly, as you can see that you are taking a matrix of the form vertices by vertices. Here the vertices A, B, C, D, and E are now selected as the rows and columns of the graph. And here how you represent? You will select either 0 and 1. If the edge is present between them, you keep them as 0. Oh, sorry. If there is an edge between them, you then write it as 1, else you write it as 0. And here, as you can see that there is no edge between A to A, so it is 0. And from A to B, there is an edge 1. So from A to C, there is an edge. And like that, you are taking it in a representation of a graph. And next one is the incidency matrix. In incidency matrix representation, graph can be represented using a matrix of size, number of vertices by total number of edges. That is, let's take an example. Before that, how you represent it? By either 0 or 1 or minus 1. 0 is used when there is an edge between, when there is no edge between them, and 1 is used to represent an edge which is outgoing. Okay, and minus 1 is used to represent an edge which is incoming to that vertex. Okay, which you have selected. And considering the following related graph representation, as you can see in this graph, A, B, C, D, and E have edges A, B, C, D, E, and A, B, C, D have what edges E1, E2, E3, E4, E5, E6, E7, and E8, taking them as columns, and A, B, C, D, E as the rows. You now write that as from A to E1 there is an edge, A to B there is an edge E1, so you are saying that A is going to B, so it is outgoing edge. Okay, so you are marking it as 1. And from E3, while you consider A, it is an incoming edge from D. So an incoming edge from D, so you are taking it as minus 1, and E4 edge is from B to D, and it is not connected in any form to A, so it is 0. Okay, let's go to the adjacency list. Adjacency list is a linked list representation. As you say, it is simple. In this representation, for each vertex in the graph, we maintain the list of its neighbors. It means every vertex of graph contains its list of its adjacent vertices. Let's see an example to know it in more. And A, B, C, D, E have a common common edge. A to B have a common edge, and A to D have a common edge. But they are the directed edges. So let's check the representation again. First you are taking the linked list from A to B. Okay, A is going to B and A is going to C. So A to B and A to C. And here B is going to E and B is going to D. So D and E. And at last you are placing this into mark to represent that it is the end of that list. Okay, and next, and it continues till it goes to the last word, that is E. And E is here now, uh, not pointing to any vertex, as you can see that E is pointing towards E and D is pointing towards E. D here you can see that as we shouldn't form any loops, so we are keeping that as there is a vertex from D to A and D to E. First we write from D to A, next from D to D, and here you can see self pointing edge. So, and then you write as D to E, because we shouldn't form any loops. If we form any loop, then it is not, it is negligible. So shouldn't form any loops in the graph representation. And here is the end of our session.